Generate filtered binary Cartesian products. Problem statement. I'm looking for an efficient way to generate full binary Cartesian products, tables with all combinations of true and false with a certain number of columns, filtered by certain exclusive conditions. For example, for 3 columns /bits n equals 3 we would get the full table. This is supposed to be filtered by dictionaries defining mutually exclusive combinations as follows. Where the keys denote the columns in the table above. The example would be read as: if 0 is false and 1 is false, 2 can't be true. If 0 is true, 2 can't be true. Based on these filters, the expected output is In my use case, the filtered table is multiple orders of magnitude smaller than the full Cartesian product, for example some 1000 instead of 224, 16,777,216. Below are my 3 current solutions, each with their own pros and cons, discussed at the very end. Solution 1. Filter first, then merge. Expand each single filter entry, for example, 0 column true, 2 column true, into a subtable with columns corresponding to the indices in this filter entry, 0, 2. Remove single filtered row from this subtable, true, true. Merge with full table to get the complete list of filtered combinations. Solution 2. Full expansion, then filter. Generate dataframe for full Cartesian product. The entire thing ends up in memory. Loop through filters and create a mask for each. Apply each mask to table. Solution 3. Filter iterator. Keep the full Cartesian product in iterator. Loop while checking for each row whether it is excluded by any of the filters. Run examples. Analysis. Solution 3. The iterator-based approach, comb_iterator, has dismal running times, but no significant use of memory. I feel there is room for improvement, though the inevitable loop likely imposes hard bounds in terms of running time. Solution 2. Expanding the full Cartesian product into a dataframe, exp_filt, causes significant spikes in memory, which I would like to avoid. Running times are okay though. Solution 1. Merging dataframes created from the individual filters, filt_merge, feels like a good solution for my practical application. Note the reduction in running time for greater numbers of filters, which is a result of the smaller calls_missing table. Still, this approach is not entirely satisfying. If a single filter includes all columns, the whole Cartesian product, 2n, would end up in memory, making this solution worse than com_iterator. Question: any other ideas? A crazy smart NumPy 2-liner? Could the iterator-based approach be improved somehow?
Try timing the following. It treats the Cartesian binary product as the bits encoded in the range of integers 0, to n and uses vectorized functions to recursively remove numbers that have bit sequences that match the given filters. The memory efficiency is better than allocating all true, false Cartesian products, as each Boolean would be stored with at least 8 bits each, using 7 bits more than required, but it will use more memory than an iterator-based approach. If you require a solution for large n, you could break down this task by allocating and operating on one sub-range at a time. I did have this in my first implementation, but it didn't offer much benefit for n equals 22, and it required the calculation of the size of the output array, which gets complicated when there are overlapping filters.
Based on Ihan's comment, I implemented an tool set-based solution. While the idea is great, this really struggles for larger number of binary variables. I suspect this is similar to large IP problems, which ain't no walk in the park either. However, the strong dependency on filter numbers could make this a valid option for certain parameter configurations. But as a general solution, I wouldn't use it.
Yes.